So, as you all know, I am fortunate enough to be testing out this new markerless, suitless mocap technology from Move.ai. Now, what I'm going to show you today is their presentation from last week's SIGGRAPH 2022. Now, unfortunately, I was not able to make it, but they were nice enough to send me this video last week, and they actually made public today. So, with that being said, grab a bag of popcorn and some coffee because this is roughly a 36-minute presentation, but we're going to be watching around 20 minutes of it. We're going to skip some parts, but yeah, let's go ahead and check this out.
So yeah, I'm going to talk about the challenge that we had to face at Move to be able to capture human motion with high fidelity without any sort of markers, so in a markerless way. So essentially, we use computer vision and AI to extract features and key points from the human body. And then we combine that using biomechanics and physics and also a spatiotemporal and probabilistic modeling approach to generate and to replicate the human motion. And then we can obviously from that output an animation. So our system takes as an input a set of synchronized videos that come from calibrated cameras. And into each one of these videos, we run human pose estimation. So you can see an example there. We track around 29 key points on the human body.
He's having fun.
And then we build a kinematic model of the human body with a specific number of degrees of freedom. And we also model the rigid body dynamics of the skeleton. And all of this information gets fed into a probabilistic estimator. So the pose estimation data drives the kinematics and the rigid body dynamics as well. And with essentially the output of our probabilistic estimator is the temporal description of the degrees of freedom of this kinematic model. So you can see here an example. We have these observations from multiple cameras that are driving the skeleton, while the motion has to be compliant with the restrictions from the human kinematics and from the rigid body dynamics. So from this, we are able to, of course, retarget this into any rigs and output the motion data into many formats. Of course, the most common one being FBX formats. What are the advantages of the system? So the system is extremely flexible and scalable. As you can see here in a quick example, we did a capture inside our office in London, which is a very small volume, about 2 by 5 by 2 by 5 meters with 4 cameras. So this system can be deployed anywhere. It is completely agnostic with the type of camera input, so the source of the camera. So you can use this, for example, with iPhones, as we're going to be demonstrating in our booth. And it's also flexible in the sense of the number of cameras that we are using. So it can go from 2 cameras all the way up to any number of cameras, depending on the volume, the number of people, and the use case. So in terms of scaling this, of course, the obvious solution here is to use higher resolution cameras. That just increases the pixel density so we can capture larger volumes. For example, with the full HD and 4 cameras, we can capture a person in about 8 by 8 meter volume, or if you go to 4K, you can extend that to 30 by 30 meters. Another way to do this is to start using like individual cell units, where you are using a fixed number of cameras to capture each cell, and then you can replicate this cell until you have essentially the volume that you want to capture. This is exactly what we did. So we actually went into a five-a-side football pitch in London.
Crazy,
we used, I believe it was 16 GoPros, and we have 2 individual cells that has eight cameras on each cell. And this was almost a 30 by 15 meter volume where we were capturing outdoors. So now I'm going to pass the word to Nikos, where he's going to talk a little bit about the challenge of now solving this problem in real time.
Real time, dude. What?
Thanks. Thanks, everyone, for being here. I'm Nikos. Thanks, Marco, for the intro. Before going to the real time, I just want to echo what Marco said. And the point here is that we don't just want to do motion capture, but also we want to capture the dynamics. We're going to capture the physics of the human body. And this is how we can get the authenticity and we make the animation to look natural, because the final animation, it obeys to the laws of physics. So it looks natural. And this is the whole point. The Problem also, it's a little bit more difficult in terms of mathematics because you have to do everything at the same time. So you have to solve everything together. You have to respect at the same time the observations from the cameras, you have to respect at the same time the physics, the biomechanics of the human body, everything at the same time, and you have to solve them both in space and time. And this is the most challenging part. But also there is one more challenge. We have to do that faster and better and better and faster. This is a race that never ends, right? We want to make things faster. We want to eliminate the latency, and this is our latest release. So until now, we had a system that runs into the cloud. Very simple. You just upload the videos, and within an hour, you have the results. But what about real time? Can you use this system in real time? And this is a draft architecture of what we came about. We wanted to create a modular system. So we use dedicated NVIDIA GPU servers, and we do the number crunching into those servers, and each server can serve one or maybe two cameras. And then the results, the digested results, they go to the mockup server, and there we do the final animation. And then we can stream this animation to Unreal using LiveLink or other 3D clients.
Crazy.
We have chosen to use this modular architecture in order to, we can, for example, expand the volume by having 8 cameras or 16 cameras or whatever. And this is the best approach. But the challenge here is not just the hardware, but also the software. And the hardware and the software, they have to work in harmony. And this was the most challenging part into the real-time system. So with NVIDIA, we had a great collaboration, and we're using TensorRT, we're using cuDNN, of course CUDA and everything. We managed to make everything run in real time. So just an example here, with a simple server, with an NVIDIA A6000.
A6000, baby.
A good processor, and of course, the cameras, they have to be cameras that they are connected. Where, for example, right now we're using IP cameras. We can have a maximum FPS of 35 frames per second. Low resolution for now, 1920 by 1080. The latency is 5 frames. We definitely want to minimize that, and the next things to do that is to use the RiverMax drivers and GPU Direct. This will drop, by our calculations, the latency to 3 frames, which is, I think it's acceptable into the industry. We can track 2 people at the same time, and the maximum capture area that we have tested this, it's 12 by 12 volume.
Dang.
Here's an example of our system running in real time in our office. You can see the left video and the right video. They are the latency is 5 frames, but unfortunately, if you see the video wall in the background, the latency is huge. We had some issues with the video wall and the Unreal client on this side. I think this is our latest release. It's going to be public next month, and well, after this conference. And our next speaker is Vincent, Director of Animation in EA. So Vince.
Yo, they're going real time. Okay, so this is Electronic
Hi,
Arts.
everybody. Thanks for attending. And yeah, so I'm the animation director of EA's Motion Capture Studio, and I had the pleasure
gonna
to
be
work
me
with
when I grow
Move.ai
up.
for the major part of this year. So for this talk, I wanted to share some of our collaborations and help show off some of the results. And so for everybody here to see, and I'll be talking about a little bit about the workflow and how our partnership happened. So let's start. So I'm going to start off with what we did in the early stages was we did a very controlled test. And what I mean by a controlled test, we did a optical and markerless test. And what we did here, you can see the talent wearing the red shirt and the blue pants. He's going to be captured in volumetric with 8 GoPros, which what do we use for this one? But you can also see markers on top of him. So it's a one-to-one direct comparison where we can see the same timeline, same time code, and we can really see the differing results. And further to that, the talent that we chose and the game rig that we chose are almost exactly same height. The shoulder he's broad just like the rig. And so something that's really important for in mocap and retargeting is to have a really, really precise a talent calibration, how the skeleton is calibrated, because if it's really accurate to the talent, you're gonna have a much easier time retargeting. And so this is something that I wanna show off right off the bat here, was you can see here that there's a green skeleton popping in and out, and that green skeleton, the green skeleton is the Move.ai calibrated rig. And you can see it's almost a one-to-one calibration with the blue rig, which is the game rig. And that one I was really impressed off the bat because it tells me that through this video-based technology, it is getting a very accurate calibration of the talent skeleton. And then I also wanted to mention for optical, it is the gold standard quality output in animation, in mocap animation. And so that's why we want to do this, and we have really good reference so that we can give that feedback to Move.ai. Where are the areas you want to improve? Where are the areas we need to look out for? And so before I get into the workflow, I'm just going to show off about 4 slides, and so everybody here can see how it looks with one talent, obviously. Like I said, 8 GoPros. So right here, you can see, I'll just play this through. I'll talk a little bit through this, but on your, I guess to your right, it'll be the optical data, and also it'll be the move data. And then you can see this is agility. We wanted to see how it would look on the fast motions, and you can see like the overall posture for the move data. The shoulders are a really good level. That's something that I personally like to look right off the bat. How is the shoulder level? Because it really gives you a good sense of how the animation, it really drives that silhouette. So that posture is really good. You can see the foot plant. It's pretty solid. It's not drifting here. And so keep playing this.
Some people are not going to be happy about this.
I'll just go to the next one.
I don't know.
For this one, it's just a series of sports moves because obviously we have a big portfolio of sports games, so we wanted to see, how's it going to look for this? How is it going to look for the other sports? And again, something that I'm always looking at is the overall posture. Is it holding up? Is it looking like what the talent is doing? And I would say it's very close. Again, you can see the feet when he's jumping around. It's not skipping from different spots, and so.
What sports was that?
And then for this one, the chair here is actually a one-to-one build to the actual chair. So this one we want to show the interaction with environment props. How accurate is it? Because that's something that's really important for us when we do big mocap shoots. We have a lot of set props. Especially if it's cinematic, there's a lot of scenes. So we wanted to see how the talent and how the results and how accurate it would be. So when I talk about, if you can look here, when he puts his hand on his thigh, you can see that for the optical, the hand rotation is more accurate here. So again, this is an example of giving all the use cases to move and to look at that and to be able to help train their, I might not be saying this right, but your processing model and how to really look at all the different cases and keep improving as we go, right? And so, yeah, right there, that's a good example right there. You can see it's going a little bit through the thigh, but again, give all the examples and keep evolving the quality right there. And the next one, for these tests, we really like using stairs because it really validates the accuracy not only on the floor calibration, but also especially for this one, again, a 1-to-1 3D build of the prop, you can see that each step for here, it's really hitting it. Whether he's going sideways, whether he's walking forward, going up. And then later on, you're going to actually see the talent walk up the stairs and jump on a ground plane, if you can just really take a look at when he does that. But he'll land right on the floor, and that's something that's really important for myself and a team, because it shows a floor calibration, and that's something you really want that to be good before passing it on to game teams. You don't want their animators to be and cleaning up the floor plane, ground penetration, and all that. So that's something we usually do. We want to do some validation. So
I haven't seen that thing go haywire at all, like the move one. Sometimes you'll see jitters and things.
I'm going to skip to the next one. So this one is actually, I don't have too much to say is this one, but this one was, we're interested to see, hey, how is props going to look? And so we did a test where we captured a ball. We had someone that's very good at soccer, and he juggled, and this is the result. We haven't, for ball is the extent of right now of our collaboration, seeing how that looks. I would imagine later on it would evolve to different sort of props, but right now this is the result that we got for ball tracking, and you can see for yourself here. It's pretty accurate. This is where I want it to loop back to focus on the workflow. So this is the part where kind of showed the results, showed how it ends up being, but I wanted to talk about the difference of the optical and the markerless workflow. So I'm just going to quickly go through it. Optical, we reconstruct the 2D camera data. We calibrate the labeling skeleton and the solve skeleton. We track and solve the production takes, and then we output an FBX with the solve skeleton. We use the optical data as reference, and then our team would retarget the data onto the multiple game rigs that we have. For volumetric, a little bit different. After we're done, calibrate the cameras. Now, we have the option to create a talent profile, what we call an actor profile. And what that means is we could capture the talent's skeleton in a very controlled environment, and then we can keep that skeleton calibration and use that for future shoots. So that's something that's very advantageous for us if we were to do future shoots with the same talents. And so the difference here afterwards, we process the production takes, but when I mean process production takes, it goes through the Move.ai magic, and then it comes back to us with a retargeted FBX. Now, we have here, this is the really big advantage for optical, is because for the track and the solving production takes, yes, it's also automated. It's actually very powerful in the automation. But at any time, our users can go in and do further cleaning up and further making sure that the data is very good. So even if the shot is very highly inclusive, if there's multiple talents, whether they're hugging each other, they're celebrating, we can go back and make sure the data is good. And also for the solving skeleton, there's a lot of the applications that we use, there's a lot of manual intervention that we can, let's say the calibrated skeleton is not exactly how we want, we can go back and refine it until the point that we think will give us the best retarget. So for optical, again, it is the optimal data quality output, and it has the user defining and user intervention. With volumetric, this is why it's so important when we collaborate, is to really highlight all these use cases where there's occlusions, where there's what kind of areas would introduce more feet sliding. If they're interacting with props, where are the problem areas? And so this is how we've been working, and to really give all those information, and for Move to be able to see all this. And it's been, for me, it's been such a pleasure going through all this because of, first of all, the back and forth, and also of how to see the evolution of all this data coming from how it looks from here, and then now it's looking like this, and it's been a very fast-paced, the evolving of the quality has been extremely, like Nico said, it's been really quick, and everything's and it's just evolving that way. So this is kind of why I'm here to kind of show how the more data we can work with, and the more scenarios, then we can when this goes into, for production, we really need to make sure that that skeleton is really clean, because the last thing we want is to have animators clean up, using an animation, cleaning up a skeleton, having problems flipping and everything. We don't want to do that in animation. We really want to make sure all that is cleaned up before retargeting and animation. And so this is where collaboration, again, where it exists, and we want everything to get as clean as possible.
Crazy.
And then for here, this is kind of an example, just through our talks, is not only just highlighting areas or issues where there's speed slides, there's something, well, what if we can improve the overall fidelity, right? So something that currently, for example, for the spine, can we improve the overall fidelity? Right now for the spine is an approximation of how the spine moves, right? So it's not a one-to-one for each spine. So something that I've asked, hey, wouldn't it be cool if we can actually, if there's a way of really measuring how the spine moves, and that would, I believe at least, it would improve the retargeting results. And so through these talks, now Move has come up with a proof of concept, and I believe Nikos is going to come back here and continue explaining this. Yes.
Okay, so I'm going to go ahead and skip the spine kind of solve whatever. If you want to, I'm going to put the link of this entire video in the description below, but I'm going to skip the spine motion. But basically, they are trying to improve the spine animation for Move Volumetric AI mocap.
Next one, we're going to talk about the NVIDIA Omniverse integration. So, Niall?
So as you can see, we don't really stand still at Move.ai, which is sort of inherent in the name. But the evolution of what we do is rapid, thanks to both collaborations with people with the experience of Vince and with the knowledge of the team we have. So I'm going to give you a look into sort of the near to mid future as to not only where we see us going in terms of the market, but also sort of future vision on how we see performance capture. Firstly, by the end of this year, we're going to be integrated into NVIDIA Omniverse. We are actively working on this via Jamie Allen, so thanks, Jamie, for plugging us into the right people, as per usual, mate. We're going to do this in a couple of ways. One is going to be a connector that's going to allow our data to flow through Omniverse and be connected either in real time or post-process data. The other element of what we are going to release later in the year is a motion library driven by Move.ai data specifically. So we are aware that there are motion libraries out there, but we also want to be able to enable and create our own. The reason we want to be able to do this at scale is that we are about to launch Markerless motion capture on mobile.
Crazy.
So rather than taking the approach of cable cameras for certain use cases, which a synchronized system in a studio or in a venue, which I'll get to, is absolutely imperative for certain use cases, we firmly believe as a business that motion capture should be available to those who often can't afford it.
Hey,
or that
that's
they thought
me.
motion capture wasn't a possibility, or they can see the requirement for it, especially as the market and society moves more towards more digital experiences. What we want to try and do is democratize motion capture to make it available to anyone on any device. So as you can see on the left-hand side here, we're actually creating an iPhone app, which presently allows you to control up to 7 iPhones with a minimum of 2 today. Store your data on the mobile and then push it to the cloud for post-processing. That will kick that back out to you in a retargeted FBX and a rig of your choice. Ultimately, we will get down to single-person capture on a mobile. We're not there yet, but we firmly believe that we will be. And where we see this being utilized is for UGC, being able to create and add your own emotes, your own content, share those with your friends, or share those as a creator, we see has been a very powerful workflow as both the industry and as the society moves forward across digital experiences. Now, a different challenge to that, and to a much different scale, is how do we capture large volumes? So through a lot of the work we've done and through the scalability in terms of cellular scalability that Marco mentioned, how do we get from a small area for a couple of meters to a 30 by 30 meter area to a 105 by 68 meter volume?
Whoa.
So we can see that
Sure,
there is a
VGH1.
need in global sports to get higher fidelity data at scale in terms of in venue and at scale across leagues and federations. This is a test we actually did recently at Wembley Stadium in the UK for the championship playoff finals for the League Two. If anyone apart from the Brits in here care about that in this room, I would be surprised. But this was actually shot just over a third of the field using 5 cameras at 4K 60.
5
We
cameras?
do believe that we can optimize this, and it's not perfect yet, but this is an out-the-box example of what we can do with just 5 cameras across a large volume. So we are going to be continuing to work on this in a number of sports throughout the next 12 to 18 months to be able to allow for much more immersive experiences, both in game engine, for visualization for broadcast, for alternative experiences in things like Unreal Engine, Roblox, etc., to be able to bring the sport to younger fans who often digest content in a very different way to the generation above them, who tend to digest it in a linear manner. Now, where we see a challenge for the future for Markerless is that ultimately we are presently tracking both the body and, well, we maybe haven't gone to as much detail in this presentation, is we're also tracking the fingers to very high quality. Ultimately, the brain trust next to me here firmly believe, and I believe because they believe and they're much smarter than I am, that fundamentally Markerless motion capture will not just be limited in the next 5 years to body, fingers, but we also firmly believe there's a future direction for us as a company. Facial animation and cloth simulation will be possible utilizing artificial intelligence and the system that we've put in place today and for the future.
That is the end of the presentation of Move.ai at SIGGRAPH. All right, so what I'm going to do now is just really talk about this thing. That was a really long presentation, but again, to me, I kind of compare this technology to Blackmagic cinema cameras. All right, and I'm going to tell you why. Back in 2013, I bought my first Blackmagic cinema camera, 2.5K camera. And even though it was the ugliest camera I have ever owned in my life, and it was just not designed well, there's so many issues with it, but it was affordable, and the Fairchild sensor inside it was able to shoot probably one of the most amazing filmic look digitally at the time for the price. And I'm comparing Move.ai to that technology because, yes, right now if you use the GoPro route, you're going to have to upload it to the cloud, rename it, whatever, like I've showed y'all in the tutorials and here in the channel on how the process works. But the quality that you're getting from Move.ai, the mocap quality you're getting, is absolutely insane. Okay, comparing that to the Blackmagic now, almost a decade later, everyone's using Blackmagic cameras. And, you know, back in the day, we used to joke in the forum and say, yeah, next thing you know, soccer moms are going to use a Blackmagic to record their kids' soccer games. And almost a couple of years later, that's actually true. That comparison for me is pretty close because if Move does the same thing the way Blackmagic Design did with the pocket cameras and Blackmagic cinema cameras, one day, potentially, this is going to be used by almost everyone, all right? I see so many similarities in the two products and the models. Move is trying to make this affordable for everyone, okay? So this comparison that y'all saw was 8 GoPro cameras, and it was compared with a 70-plus optical camera system. And I'm just going to throw some numbers out there. I think some optical cameras for 16 it can cost you 100,000 to 150,000. And they compared, as you saw, they compared it to 8 cameras using Move.ai. So again, 8 cameras versus 70 plus optical cameras, and the quality are fairly similar. And this is why I think Move.ai is in the position to really flip the mocap world upside down. Now they're talking about iPhones, all right? And we were talking about prices, and I said, iPhone 8s, you can get those used for $200 a pop. Okay, I'll buy 4. So I have an $800 hardware plus tripods, which I can get cheap wherever. 4 iPhone, 4 tripods, and you have a mocap hardware. Now, obviously, Move.ai, they still have to figure out the processing and the price per processing when using their service. So with that being said, every single company that has asked me, how much should I charge for X, Y, and Z, I always respond with the same exact thing. Who are you trying to sell your product to? And I know people throw the word around democratizing. We're going to democratize mocap. We're going to democratize facial motion capture. And obviously you saw in the presentation, they also said democratizing, making mocap for everybody so that everybody can use it. And I'm not going to lie to you, I haven't seen that in any company yet. So for me to believe this, I have to really see what's going to happen. The price. So with that being said, they need to figure out who they're going to try and sell this product to. If you're trying to sell it to gamers, as you also, they had like a video game kind of example there, you're not going to be able to charge them $5,000 for a mocap suit or mocap solution. That's out of the window. They have to figure out where they're going to have to price this thing. Now, obviously, I've given my 2 cents on the whole thing, my opinion on the entire thing. And honestly, they're very receptive of that, which is freaking crazy for such an amazing company like this. These guys are geniuses, right? Breaking barriers. But they have to figure out who they're selling to. If we're lucky enough, and they really do mean when they say democratize the mocap world, the hardware, we already know that's going to be around two iPhones, 4 iPhones, probably solid there. But the software is still a question mark. And the next thing that is going to be a big challenge for them is actually delivering this thing. I've seen a lot of companies with great ideas, but they fail to deliver it. What I mean by that is, if you have this amazing product, you need to be able to explain to people how this works and why people should buy your product. Okay? So my challenge to them is, hey, you need to be able to translate this to the common people, to the gamers. If you want to sell to gamers, you need to be able to break this process down to gamers, right? I don't want to see a zip folder with 12 documents teaching me how to use this thing. Because I'll tell you what, I'll delete that. If you have a great product, you need to be able to deliver it properly to your audience. This is really complicated technology to many, so they have to be able to translate this into layman's terms. But to be honest, if you go to their website right now, I followed that tutorial to the teeth, step by step, and I was able to follow along and use with the GoPro method. But from what I'm seeing here and from talking to them, it looks like for the iPhone method, instead of uploading a lot of files all at once, you're only going to get one. It's going to be uploaded to the cloud automatically. You don't have to rename. You don't have to copy and paste files. That right there is easy to use, right? And yeah, I mean, honestly, I'm sorry. That was probably a really, really long video, but I just wanted to give y'all my 2 cents in this whole Move.ai versus Optical, because it actually, I'm a consumer as well. I'm in the market for a mocap. You know, I want to know what the best options are. I get asked all the time, what is the best mocap? What is the cheapest mocap? Is there any free mocap? And again, I'm sharing this with you all because I want this right here to be in your radar. And no, I did not get paid to make this video. I honestly, that's bad on me because to be honest, a lot of people know I don't get paid to make 99% of the content I make here. But when I truly believe in a company, like I did back then with Blackmagic cameras, I can kind of see this thing really doing some damage later down the road. And I can guarantee you it's probably making some companies sweat a little bit, if not a lot, because this is some freaking black magic right here.